Good morning, everybody. I am Anusha, Assistant Professor of Computer Science and Engineering, Institute of Aeronautical Engineering College. In my videos, I will be discussing about the subject Programming with Objects, which is based on Java. So, in the last video, we have discussed about the use of static field, what is the importance of access control and the use of this keyword. Now, in today's video, we will be discussing about overloading methods and constructors, recursion and garbage collection. What do you mean by overloading? So, overloading is a type of polymorphism. As we discussed in the initial classes, there are two types of polymorphism. One is overloading and the other is overriding. These are the two types of polymorphism. So here in this overloading is static polymorphism which happens at compile time, and overriding is dynamic polymorphism which happens during runtime. So there are polymorphism means it is the ability of a method to exist in different ways, So here in Java we can achieve polymorphism by overloading methods, but overloading of operators is not supported in Java by the user. But we can say that the plus operator is being overloaded. In case to use, it can be used as addition operator when it is operating over numbers, and it can be used as a concatenation operator when it is used on strings. So that is provided as built-in. It is not provided by the user. But in Java, it does not support operator overloading as in C++. So this overloading is also called as ad hoc polymorphism, and overriding is pure polymorphism. So now how can the method distinguish between the overloaded methods? So in overloading methods, the methods will be having the same name, but the parameters will be different, or the signature will be different. So there in a class there can be more than one method with the same name. But they will be differentiated based on the parameters or the signature of that method. So if the methods can have same name but different parameter, the number of parameter may be different, or the type of the parameter may be different. In these two cases, so using that too, the compiler will identify which method has to be invoked at that particular call. So for so if when an overloaded method is invoked, Java uses the type or the number of arguments to determine which version of the overloaded method to be invoked. And there may be cases wherein there are where it doesn't find an exact match. So in such cases, it allows automatic type conversions that we will see in our example. So overloading means it is a type of static polymorphism. It is also called as ad hoc polymorphism, and it will have same name. The methods following overloading will have same name, but their parameters will be, or the signatures will be different. That means the type and number of parameters passed will be different. So let's look into an example of overloading. Here we have a class named as overload demo. So in overload demo, we have classes, we have methods named as test, which is overloaded. There are 4 versions of test. This is one version, second, third, and fourth. So all these methods have the same name, test. Now, this first test doesn't take any parameter. The second test takes an integer parameter. The third test takes an integer, 2 integer parameters. But the fourth test takes only a double. So they all differ in the number of parameters passed or the type of the parameters. Here, even though they both are integer, the number of parameters passed are different. Here there are no parameter passed, but here in this case, it is a double parameter that is being passed. Based on the parameters passed at the time of invocation, the corresponding test method will be invoked. So let's look into the main method. So we have a class named as overload. We have the class overload. So in overload class, we are creating an object of this particular class and we are trying to access them. So when we try to access them, we are calling ob.test. Now in this ob.test, it is not passing any parameter. So when ob.test is invoked, the compiler will check which part it has to invoke of these. So it will see that the first version of test method doesn't contain any parameters. So it will invoke that and the output will be no parameters. Next, it is invoking the test method with single integer parameter. So the compiler will check all the versions and it finds that the second test version is the one with single integer parameter. So it will display the contents of A as 10. Next, third case, it is calling the test with two integer parameters. So again, the compiler will check and it finds that the test method is this test method will be invoked and it will display A and B as 10, 20. Next, in this case, it is invoking I. Again, I is an integer variable. So it is again taking a single integer. So this method will be invoked and it will display A as I value is 88. So A value will be 88. Next, in the last case, it is invoking test method with a double variable. So the double value is being passed to test. So the corresponding test method will be invoked and it will display double A. It will display double A is 123.25 and also it is returning A star A. So the product of this number will be returned over here, returned to the called method. So it will store 123, square of 123 will be stored into result and that value's result will be displayed as that particular value. So in so the statement will be displayed. So this is about overloading method. So wherein overloading is the concept of a polymorphism, which is a static polymorphism. It is also called as ad hoc polymorphism. And in static polymorphism or overloading, the methods will be of the same name, but the parameters or the parameters passed to it will be different. So so depending on the number of parameters or the type of parameters passed, the compiler will invoke that corresponding method. So that is about static polymorphism. Next we'll look into one more example of a method overloading. So here in this case, we as I've told you in the beginning, we have, let's say we are finding area. We have a shape to shapes area, and from that we need to find the area of this square, a rectangle and a circle. So this area, this class may contain a function named as area, and that area method can be used to find the area of the square, rectangle or circle or triangle. So in our case, let's say we are using we have a method class named as area, and inside that class we have the method area with an integer. So this area is meant to find the area of the circle. This area is meant to find the area of the rectangle. Area of the rectangle. And this is kept in a comment line, but this can be used to find the area of the square. Now, once we come into the main method, we are creating an object. We are initializing the R, L and B to 10. Then we are creating an object of it. And now we are finding the circles area. So to find circles area, we have to pass the radius to it. So we are passing the radius. So the radius is of type integer. So in this case, it will check which is having integer, and it finds that this is the one which is having a single integer. So it will use this part to execute the program, to invoke that, to work on that area, and it will find the area as pi star 10 star 10. So math.power is a function or is a method. This POW is a method which is available in the math class to find the power of some elements. And math.pi is a constant inside the math class. Now this math class, these math class are static classes. That is why we are able to call the class. We are able to call the members of the math class using the class name itself, since they are static classes, static members of that particular math class. So at this point, this area method is being invoked. Area method for finding the circle area is being invoked, and it will find the value as 3.14 into 10 into 10. So we will get it some value like say 314. So that value is returned here and it is stored into CAR. So we get 314 over here. Next we have, we are finding the area of a square. So in this case, we are using two parameters. So to find two parameters, it is passing two parameters. So it will invoke this method with two double parameters. L and B are double type. So we invoke that as finding the area of the rectangle or the square, and you find it with the formula L star B. So you get values as 10 into 10, which is 100, and that 100 is stored into AR, which is returned, and that will be caught over here. So you get square as 100. So you get the output as, first initial output was area of circle is equal to 314.00 something. Whatever is the continuation, like you will get the decimal part also. Then area of the square is equal to 100.00 since it's the double. And we have area rectangle also called similar, which is taking two different values of L and B, and that is also will invoke the double. Now one point to be noted here is that in case here in our example we have the square method written to call the we have used the square method to call the area with two parameters. But in case we just need a single parameter, so but we have defined the length of the side of the square as integer. Let's say we have defined the side of the square as int s equal to 10, let's say, for example. Okay, so and let's say let's say No, in this case, we cannot use int because it may invoke area, this circle method. So let's say we have double itself. We have double. So if we define this as double, then we will be passing only a single parameter. That means we will be calling a single area of S. So in this case, since S is set to double, it will again invoke this in case this was put as we have uncommented it. Now there is one more point to be noted. Like in the previous example, we have seen a method with single integer parameter and single double parameter. Now let there be a case wherein this method is not defined. So if this method is not defined and we have this being called in the main method, then the parameter passed to test is an integer, but we don't have an integer method, overloaded method for an integer. So what happens here is that this will be widened. It will be converted to the next higher value. So here we are passing as integer. So the next higher value is double. So it will call the double the test version of double method to invoke. So that is why I have told you that it will implement automatic type conversion if no exact match is found. So here in this case, in case we don't have this test method defined with an integer, but we are calling the test method with an integer, and we have a double version for that, then this 10 will be widened to form this integer 10 will be converted into double 10, and this corresponding test method will be invoked. Next, let's look into constructor overloading. So as we have seen how we can overload methods, the same way we can have constructor overloading also. That means we have already seen there are three types of constructors, one with empty constructor and a parameterized constructor and a default constructor. So in our example, we are making use of parameterized and a constructor without any arguments. So in that case, how it will be working. So in our case, let's say we have the constructor for box with height, width and depth defined with by these variables. And then we have four constructors defined over here. This is the first constructor, which is initializing the box to -1. This values are set to -1. Then we are calling constructor with a single parameter, then another with 3 parameters, and a single parameter of object type. So these are the 4 type of constructors which is available in this class. So here in this case, we are creating a reference of mybox1. At this point, we are creating a object mybox1 without any parameter. So in this case, it will invoke the constructor without any parameter. So this case, it will invoke the first one. So this constructor will be invoked. The mybox1 will be invoking this constructor and its values. So this is mybox1, let's say. So this is the width, height and depth. So mybox1 is set to is invoked without any parameters. So it will set the values as width, height and depth as -1. So -1, all these things will be set to -1. Next, we are creating an object mycube. So an object mycube will be created with parameter 7. So mycube will invoke the constructor with single parameter. So this is the constructor which will take single parameter, and it is of type double. So this value is 7, this value being an integer, but we have only a constructor of type double, so this value will be upgraded to form double, and that width, height and depth is set to whatever is being passed. So here width, height and depth will be set to 7. So this is for mycube. Next, we are creating another object, mycube, mybox2. Another object, mybox2. With this is width, height and depth. So mybox2 is invoking with constructor with 3 parameters. So this particular constructor will be invoked, and it will set the width to 10, height to 20 and depth to 15. Now once this is the second case. Fourth case, we are creating an object myclone. Object myclone is created. So that myclone is using mybox2. So mybox2 is being used as its parameter. So it is this mybox2 is what it is, an object. So the constructor which is taking that object will be taken. So this constructor will be invoked. So it will set the width, height and depth to. The width, height and depth of myclone will be set as that of mybox2. So mybox2 is what? This is our mybox2. So mybox2's height is 10. Width is 10. So myclone's width also will be 10. Then mybox2's height is 20. So when you call ob.height, it is accessing mybox2's height. mybox2's height is 20. So that 20 is set to the invoked object's height. So you will get it as 20. And similarly, mybox2's depth is 15. So ob.depth means ob.depth is mybox2's depth, which is set to the myclone's depth also. So we get here as 15. So 4 objects are being created, and then we are calling some of the we are calling the volume method on these. So when mybox, when volume is called, this will be creating invoking the one without parameters. So these two will be invoking the one without parameters. So you get the volume to be -1. Then my cube volume means it will be in pass. My cube is, this is my cube. So it will find the product of height, width and depth using the volume method, and my cube's volume will be 7 cube. So it will be 343. Then similarly, mybox2 volume. mybox2 is 10 into 20 into 15, which is again, it is coming to 3000. Sorry, it is coming to 3000. And myclone volume also, which is taking, myclone volume will be mybox2's volume, which is again 3000. So this is about constructor overloading. So as we can have the methods as well as constructor overloaded in Java. So overloading can be achieved by making use of having the same methods or the constructor with the same name, but they will differ from each other in the signature. That means the number of parameters passed or the number of or the type of the parameter passed to it will be differing in each case. So that is about overloading. So here we have the output. mybox1 is mybox1 is having the output -1, my box and my box 1 will be having -1, since they both are invoked over they both are invoked on a constructor without any parameter. So this constructor will be invoked for my box and my box 1. Hence you got the output as -1. Then cube is having 3. My cube is having all the sides set to 7, so you get it as 343, and my box 2 and clone is 3000. Next topic is recursion. So recursion is something in which the process or the method will call itself. When the method calls itself, it is called as recursion. So that means it is a process of defining something in terms of itself. So let's say we have a method f. That method f will again call itself to do some operations. To do some operations, this method f is calling itself. So the process of defining something in terms of itself is called as recursion. And the method that calls itself is said to be recursive. So let's look into an example wherein we are finding the factorial of a number. So to find the factorial, we have the method fact, which is taking up an integer variable, and then we have an integer variable to store the result. So how do we find factorial? If we say it is 3 factorial, then it is 1 into 2 into 3. So let's say first in the initial case, we have factorial of, we have to find the factorial of 3. So if we want to access the fact method inside the factorial class, we have to create an object factorial f. So we want to find the factorial of 3. So this is called. So the value of 3 will come into n. So n is set to 3. So inside factorial, we say that 1 factorial is 1. So if n is 1, then we have to return 1. So, and or else if n is not 1, then we have to call itself. If we are calling that factorial itself. Okay. So here, in order to find the, let's say we want to find 3 factorial. So 3 factorial is about 2 factorial, 3 factorial is 2 factorial into 3, right? It is, this part forms 2 factorial and into 3. So 3 factorial is 2 factorial into 3. That means fact of n minus 1 into n. So we have passed 3 here. So it will be fact of 2 star 3. Now we are calling fact of 2. So what will fact of 2 do? Again, it will come into factorial. So n value will be 2. Is n 1? No. So it is not yet 1. So it will come to this line. So the result will be calling fact of 2 minus 1. So what is 2 factorial? 2 factorial is 1 into 2. That means it is 1 factorial into 2. So we have factorial of 1 into 2. So we have factorial of 3 calling factorial of 2 into 3. Then again factorial of 2 is calling factorial of 1 into 2. Right? Factorial of 1 into 2. Now what is factorial 1? So factorial, when it is calling factorial 1, n value is 1. So n is 1. So it will return 1. So factorial of 1 will be 1. So factorial 1 will be, factorial of this value 1 will be returned to factorial of 1. So this becomes 1 star 2. So in the next case, so we get factorial, this value 2 will be returned back to factorial of 2. So factorial of 2 will get the value 2. So this is 2. So it will get value 2 star 3. It was before it was 3. Now factorial of 2 is value 2. So it will return 2 to factorial of 3. Since factorial of 3 is fact 2 star 3. So this 2 value will be returned to this. And finally the product of 2 star 3 will be computed and return to the method which has called factorial of 3. So you get 6 over here. Now similarly, so in the output we will get factorial of 3 is 6. Now let's say let's find factorial of 4. So we are calling factorial of 4. So factorial of 4 means it is calling factorial, here you will get 4. So n is not 1, so it will come here. So it will be factorial of 3 star 4. So it will be factorial of 3 star 4. Then now since factorial 3 is being called, it will call itself. So n will be 3 now. So factorial of 3 is factorial of since n is not equal to 1, it will call factorial of 2 star 3. So it will call factorial of 2 star 3. So 3 star 4 star factorial of 2. Now this factorial 2 n is 2, so n is not 1, so it will again call factorial of n minus 1. So you get factorial of 1 star 2. Fact of 2 will be factorial of 1 star 2. Then what is factorial of 1? Since n is 1, n value is 1, it will return 1. So this factor of 1 will be 1. So this value is 1 now. So 1 into 2 is returned to factor of 2. So you get factor of 2 as 2. Then 2 star 3 is returned to factor of 3, which is 6. And factor of 4 will be 6 will be returned to the caller of factor of 3. And 6 star 4, that is 24, will be returned to factor of 4. So you get 24 as output over here. Similarly, we have the factorial of 5 also executing. So here the factorial method is calling itself, and there should be one exit point wherein it can return some value to the. So this is the basic point of return, wherein when the n value reaches 1, it will be returning some constant values so that it doesn't become a continuous loop. Next is garbage collection. So we have seen we have already seen that in C++, the programmer itself has to use the methods like malloc and calloc, then free methods to remove the data, to clear up the memory which is being utilized in the program. So, but in Java, there is no method which has to be used by the programmer. Instead, Java handles the deallocation of memory automatically. The procedure, that procedure is called as garbage collection. So, if there are no references to an object, then, and that object is no more in use, then that memory occupied by that object can be retrieved back and given back into the memory pool by the automatic garbage collection. The process of freeing the memory automatically is called as garbage collection in Java, and it is a completely automatic method which occurs at it occurs at irregular intervals. It occurs sporadically. So if we want to, if there may be situations in which these objects are holding some resources, non-Java resources like file or something. So in such cases, if that file has to be released, then we make use of the finalize method. So to free an non-Java resource held by the Java object, a mechanism called finalization is performed, which make use of the finalize method. So in such cases, since that object is holding that let's say file or some other resource, it has to free that object before its destruction, has to free the free that resource, and the steps which is required to free that resource will be specified inside the finalize method. So to add a finalizer to a class, we simply define the finalize method, and the Java runtime calls that method whenever it is about to recycle that object of that class. So there is a method named as finalize which can be used for releasing some resource held by the object. So until today, until this point, we have discussed about overloading methods and constructors. So overloading is the process by which method can exist in various forms. In overloading, the method names will be the same, and the signature of the method will be different. So overloading can be done over methods as well as constructors. Then also we have discussed about recursion, wherein it is the process of a method calling itself, and garbage collection, which is an automatic process of freeing up the memory pool and freeing up the unused objects and adding that memory into the memory pool. So to prepare these slides, I have used the textbook Complete Reference by Herbert Schild. And that's all for today. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.